Assalamu alaikum wa rahmatullahi wa barakatuh. Today is our 8th lecture uh, in the course PHM 30502 Manufacturing Pharmacy. The title or the topic of this lecture is Documentation Control in GMP. We will discuss about uh, documentation requirements in pharmaceutical industry. You remember we mentioned this sentence during our previous lectures. We said that in industry they always say if it is not written, it is not done. Okay, or if it is not written down, it didn't happen. Okay, so the basic rules in any good manufacturing practice regulations, whether the PICS or FDA or European Union, they all specify that pharmaceutical manufacturers must maintain proper documentation and records. Okay, so you claim that you did anything, but you don't have a proper documentation regarding this process or procedure that has been done. The inspector automatically will consider that it has not been done. There must be always documentation and records. Okay. There are benefits from documentation. Number one, documentation inform or provide information on when, where, who, why, and how to complete tasks. And as we mentioned also previously, as a general rule, you should not do any procedure or work out of from your mind or based on you rely on your memory. You should always follow a written procedure, and this will reduce the chance of making errors. Okay. So there will be documents available that have the information on certain tasks, who should perform this task, and what is the purpose of performing these tasks, and how the procedure itself is written, the steps one by one. If you follow, then you will be able to complete the task successfully. And it will also tell you about the location, the instruments that you will use, and so on. Okay. These tasks can be a manufacturing process, can be running an instrument, maybe lab instrument or instrument in the manufacturing site. There can be, for example, an SOP or a document telling you how to run the autoclave. So it will tell you number one, what to do, number two, number three, and so on. So if you follow, then you will be able to run the autoclave. Okay. The second benefit is it will provide an evidence that will prove that the tasks has been completed as they should be. Okay. How? Now we almost refer to two types of records. The first one is about records containing instructions how to perform tasks. The second point is talking about another type of documents which are more like records. So if you perform any operation, then you will record, there will be a record or documentation that these steps has been performed. Simply like for each step, somebody, the one who performed, will sign, will date, then means that this one has been performed. Okay, so it will provide an evidence that prove that the task has been completed as they should be, because you follow the instructions written, and then against each instruction you have signature. Then this means that you followed these instructions exactly, you perform the task as it should be. Okay. Documentation is the key to GMP compliance, and it ensures traceability of all development, manufacture, and testing activities. Okay, so it is evidence that you comply with GMP. GMP is telling that you need to have validation process, for example, for instruments, for processes. Then in order to prove that you are performing validation, then you should have two types of documents, as we mentioned. One is having the instruction how to perform the validation. The other type is records. So when you perform validation process, then you write the findings, you sign. This means that you have performed the validation. Okay. So this is an evidence of your compliance to GMP when it comes to validation. GMP is telling, for example, that you need to do for example, quality control tests for the raw materials that you receive, and you have to accept or reject them based on uh, whether they comply or they don't conform or they don't conform to the specifications. So you must have also two types of document. One is giving the instructions, the testing methods, how to test the raw material. Another one having the specifications of the raw materials. For example, we talk about saying phenolic acid, BP, then it will mention that what are the specification of the phenolic acid BP that you should use as a reference. Okay, and then testing methods, how to test each specification of them separately, and then there is a record that you will have to key in the test results. So by having these types of documents, then you have evidence that you comply to the GMP requirement about testing of raw materials and so on for all the processes or procedures that will be done in the pharmaceutical manufacturing facility. Okay, so when inspectors come or auditors come to your facility to audit for inspection to ensure that you are uh, following GMP guidelines or comply or you are complying to GMP instructions, then this documentation is your evidence. It will provide the route for auditors to assess the overall quality of operations within a company and the final product based on your compliance with the GMP regulations. Okay. If we ask ourselves, why did we need to own these kind of things? Why did we need GMP regulations? Why did we need this documentation and so on? Always systems are not perfect and they don't start to be very good from the beginning, but systems usually start to be very simple, less regulated, but usually problems on the way or disasters sometimes will force people to make a review and try to find what was the problem and uh, you can say set up new rules to improve the system. Okay, so actually this kind of documentation requirements and inspection concepts and so on, they started with at the year 1972 in a city or place in UK called Devonport. There was an incident that happened, resulted in at least 5 deaths. The problem there was with the sterilization process in the hospital. So, drug products supposed to be the dextrose intravenous solution prepared inside the hospital is being autoclaved after preparation to render it sterile. So, if the sterilization process is not successful, then some of them may be a cause of infection to the patient administering them, right? So, what happened in this city is that in one hospital, uh, drug products supposed to be sterile, dextrose intravenous solutions, became contaminated, and the recipients, the patients who administered them, developed infections. And this resulted in 5 deaths among those who has been infected. Okay, so what was the cause? There was unwritten change to the autoclave operation. So there are standard operation instructions for autoclave. They were not being followed exactly. There were some changes in the operation of the autoclave, and these changes have been communicated orally between operators. No documentation. Uh, Everything looks like they followed the standard procedure, and this variation resulted uh, in that this product, dextrose intravenous solutions, are not uniformly sterile. What's the meaning of not uniformly sterile? Means that you put certain number of bottles in the autoclave, and not 100% of them became sterile at the end. Some are sterile and some are non-sterile. Okay, So after these infections happened and 5 patients died, of course, this raised an alarm or sign, and there was an inquiry, official inquiry. They call it the Clothier inquiry. So committee came, they examined the causes of this problem. They try to find out what are the factors that led to this problem. They identified several violations of what we follow nowadays and call it the GMP. Okay, so the way they happened was against the concept of GMP that we have nowadays. Some of the factors they identified and affected the safety of the drug product included inadequate maintenance. So the autoclave itself, there was no adequate maintenance for it. Uh, Personnel, when we talk about then instrument validation, there is a concept nowadays. We call it validation. You have to validate the process, you have to validate the instrument as well. So instrument must be validated and there must be an evidence that the instrument performance is as expected, otherwise cannot be used. But they have problem in instruments, no validation, and they still use the instrument that have problems. We have a concept nowadays in GMP that talk about personnel and training of personnel. There was a problem at this time. There was inadequate understanding of autoclave operation among the operators. Okay, and also we have also recommendations in GMP regarding the change control. And the variations must be documented and must be also have justification. So usually at this time they used to have regular deviations from the written production instructions, and this was done in order to compensate for the equipment malfunction. So there is a problem with the equipment. They made some change that they did not document in the procedure for operating the instrument, the autoclave, and they thought that by doing this, they will overcome the performance problems of the apparatus. But actually, what happened is that they did not overcome, and there was a problem of inefficient sterilization. Okay, so some of the product is not sterilized and caused deaths of patients. Okay, these factors resulted in sterilization cycle that didn't ensure that all vials in the autoclave were sterilized. Thus, some doses were safe, while others led to sepsis in patients who received them. Some of those patients that had sepsis died. Okay, so to rectify this problem, to improve the process and prevent another prevent this problem from happening again, this led to or helped to define sterility assurance in operational way. Okay, processes and requirements for equipment validation were created. Legal right of inspection was explicitly given to the agents. Okay, so then they came with the concept of equipment validation. It is important. No equipment should be used if no validation, means if no evidence that this equipment performance is up to the requirement or specifications. Okay, and same time they gave the right of inspection to an agency that have the right to inspect and ensure that the institution is following the regulations and there is no not breaching it. Okay, so what is meant by documentation? Documentation is defined as a systematic procedure of preparation, checking, verifying, issuing, storing, and reviewing of any documents. So when we discuss the documentation, we should discuss about all these aspects, about how to prepare documents, the checking step, verification, issuing, storing, and reviewing. When we talk about preparation, then writing the document, writing the draft, what is the standard format that we should follow, and then checking, this is to kind of review in order to ensure that the document doesn't have um, any mistakes, nothing wrong in the document. All information are correct, written in a proper way. When it comes to science and scientifically, and even when it comes to grammar and writing. Okay, verifying, ensuring that the information is correct. Issuing means we already have a final draft certified, and the company have probably a number, and it became officially recognized in the place and can be followed. And then how do we keep the documents? And reviewing it. What's the difference now between reviewing that we mentioned at the end of the sentence and checking? Okay, so checking is when you prepare the drafts of documents and you want to ensure that it is free of errors. But then these documents will not be followed lifelong or uh, without any review. Okay, so from time to time there may be some changes in regulations. There may be, say for example, we make a document, batch manufacturing record, for example, or say master file. Talk about uh, master formula. Okay, so you prepare the master formula for certain product, and after some time we changed something in the formula. Then we have to make a new draft, another version of the master formula of this product. So this is a kind of review process. Probably there is a document about certain procedure, and then there are some new regulations, probably specifications, and now the specifications changed, something added, something changed, something removed. Then we have to make a review, make another draft, and we consider these changes. So you have, this is the review process. So documents may be updated. So we may have version 1, version 2, versions 3, and so on. Okay. So when it comes to documentation, what is the responsibility of each party in the manufacturing facility regarding these documents? When it comes to the management of each operational site, the management of the facility itself, their job or their responsibility is to define responsibility for origination, who will make the document, distribution, to whom it should be given, those who will follow or implement, maintenance, about the storage of the documents, change control, if we do any change, how the change will be done, how it will be approved, how it will be traced, okay, and archiving all GMP documentation and records within any department or unit. Usually we keep archive and we keep all the documents there and records, and there are also, when it comes to documents, they will be kept all the time as long as they are being implemented. When it comes to records, they have certain legal requirements, certain recommendations, how many years we should keep them, and then you can then destroy them after this period ends. Okay, the document owner, or the one who makes the document, their job is to ensure that all the aspects of documentation and records management specified in form of standard operating procedures. Okay, so there must be an SOP about documentation itself. Okay, there will be SOP or document giving instructions on how to make documents and how to keep them and all the aspects we mentioned before. Okay, when it comes to all associates, means those in different departments of the pharmaceutical factory that may have relation to some of the documents we make. They are the one who's supposed to follow, implement, and so on. So their job is to ensure that all GMP activities are performed according to the official SOPs. Okay, so they should follow the SOPs, the official SOPs in all the activities in the pharmaceutical manufacturing facility. They should not do any deviations And if deviations for valuable reasons has been done, then should be reported to the supervisor and adequately documented. Okay? So if you have, for example, a procedure telling that you have to use the as a standard operating procedure, the mixer at certain speed for example, 30 minutes. Uh, as we mentioned before about, for example, in process control, you send samples, you find not yet uniformity of mixing achieved, you need to extend the time till you achieve the uniformity of mixing. Okay, so this is a deviation, should be recorded, the reason is known. Okay, in any manufacturing facility there is a department called quality assurance department, or a unit for quality assurance unit. Okay, their job is usually to ensure via organizational measures, there are regulations in the organization are followed, stating that you have to follow the GMP, you have to have appropriate documentation. There are SOP for the documents for all aspects regarding documentation. Everybody must follow. All the departments must follow. Okay, so they have to ensure via these measures and via auditing. They are kind of internal audit. So audit or inspection can be from inside the institution and can come from outside the institution. You want, for example, your company to be ISO certified. So the agency that is have the authority to give you ISO certificate will come for inspection. You need to get or to be GMP certified. Then you apply, and then the agency that gives the GMP certificate will come and inspect your facility. They will review all the measures of GMP followed in the facility, and if they are adequate, then they issue the GMP certificate. This is external audit, but you must have your unit inside your company that will prepare you for this. They will they will all the time do internal audit. They are from inside the company, and they ensure that all these regulations are followed, implemented. So by this way, you can maintain your certification status. Okay. So you want to apply for GMP, you are ready. You got the GMP, then any inspection comes at any time, they find that you are complying, and your certification will be maintained, okay? Will not be revoked, and so on. So they should also ensure that GMP documentation and the record systems used within the operational unit are complete and comply with the relevant GMP requirements, and also that the requirements of the SOPs are followed. So they must ensure that you have the appropriate documentation in all the units, manufacturing unit, quality control unit, for them themselves inside the quality assurance unit, in the store, water treatment unit, all the units of the manufacturing facilities must have the appropriate documentation according to the GMP regulations, and same time they are following the SOPs they have. Okay, not they have documents telling that you have to go right, but when they work they go left. No, they must be also following the documentation. Because the overall um, objective of this documentation is to prevent errors and to ensure that you produce a product with the intended quality. Okay, so in order that your procedures or instruction documents, they have uh, instructions. If you follow, then your product will be produced by the quality you want, and there must be a records proving that you followed these procedures. Then if you follow, means that you are performing the procedures that will result in a product with the required quality. This, so the end result will be having a quality product. Okay, some documents we call it quality modules. We have quality modules related to different areas in the manufacturing facility. Each of them will talk about different area. It will describe or cross-reference requirement for specific documents or record, including ownership, content, authorization, and change control. Okay, so they will cross-reference or specify who should be, for example, in quality control, the testing methods, certificate of analysis, all types of documents we use. Who is the one who will draft them, the owner that will use them, what will be the content of each document, how it should be authorized. Quality control will prepare the SOP or testing method. Then who will approve it, okay, to be used. So this is the authorization. And then if we want to make any change, how to control this change. If we make change the testing method, for example, so how this change will be done. And so you make new draft, a new version of the testing method, for example, with a new date, and then it will be authorized also, and then the previous one will be cancelled, not followed. The most recent draft is the one will be followed, and so on. Okay, and control procedures when it comes to storage, security, and so on. In order to ensure that we are doing the documentation activity in the right way in manufacturing facilities, then they came out with guidelines for good documentation practices. Okay, so up till now we have GMP, good manufacturing. Part of the good manufacturing practice talking about the documentation. So good documentation practice is within the wider scope of good manufacturing practice. Okay, it's a component of good manufacturing practice. So up to now, how many good practice we came across? You have good GMP, you have good laboratory practice, GLP. We came across good distribution practices, right? And good storage practices, and now we have good documentation practices. All of them are parts of GMP. A GMP facility, when they should follow, we have so many sections in the GMP guidelines to follow, some about manufacturing, some about lab. So when we work in the lab and do the quality control tests, we should follow the GLP principles, some about the store, so good storage and good distribution practice, some about the documentation inside the facility. So this is the good documentation practices. Okay, so it is an essential part of the quality assurance system or from the GMP. Okay, the objective from having appropriate documentation, as we mentioned, one of them is that we will have clearly written procedures, and then you don't work based on your memory. When you work, you follow this procedure, written procedure. So this will prevent errors that may result from spoken communication and help to achieve robust decisions. Okay. Number two, clear documentation permits tracing of activities performed. So if I have, as you mentioned before, for example, in case of product recall, if there is certain problem in a certain batch, then we want to find out what was wrong, what was the reason for having this problem in this batch. We can trace, we have appropriate documentation for the manufacturing process. We have documentation for the quality control tests. We have documentation for the raw material, for everything. Then we can refer back to the documents and try to find out what was the cause. Okay, so we can trace the activities performed, when they have been done, how they have been done. Okay, you have the results of in-process control samples, you have the results of finished product samples, you have the documentation of the all the steps during the manufacturing process. You have the data about raw materials, packaging materials, everything. Okay, and in order to be able to trace, then the supporting data set needs to be reliable and complete. So we must have appropriate documentation, correct, true, and done at the same time. You do the thing, you are performing the procedure now, you run now the mixer, then you write down, you sign. If any in-process samples, in-process testing done beside the tableting machine, whatever, you concurrently at the same time write the results, okay? The actual results without change, and should be complete, should have all the data required, okay? So good good documentation practice, in abbreviation we write GDocP. Good documentation practice should be followed in order to ensure all records, whether they are electronic or paper-based, they can allow for full restriction and traceability of GXP activities. Okay, so full reconstruction, then every time uh, you do the certain procedure, you follow the same SOP steps. So every time you can do it, the procedure in the same manner. And if you have records of all the steps done, the results of uh, readings of machines, for example, or in-process quality control samples or others, then I can also trace. The meaning of GXP here is talking about manufacturing practice, you are talking about laboratory practice, distribution practice. So GXP is something general for any practice, good practice in the hospital, in the manufacturing facility. If you have appropriate documentation, you are following good documentation practice, then it will allow full reconstruction and allow traceability of the activities that has been done following the regulation of this good practice. Okay, for example, you have documentation in the lab, you follow good laboratory practice, GLP. So if you have good documentation practice in the lab, then the documents you have will allow you for full reconstruction of all the procedures or activities you do in the lab, the laboratory practice, the testing procedures, and also traceability. You can trace the uh, the activities that has been done. And one of the basics that every analyst must have his own logbook, and the same way we followed in the lab, the template I gave to you for the worksheet, we call it. So you have a book in the quality control, and you have to write the procedure you are performing. You write down all your calculations. You attach the printouts of any machines you are using. You have chromatogram from HPLC, chromatograph, you attach the chromatograph. You weighed your sample. You weighed your standard on the balance. Then you have printout in the balance you attach in your logbook and so on. So if something wrong happened, for example, your sample failed, and you want to make a review to check, probably the problem is not your sample. So you can trace what you have been done. You can look at the procedure you wrote. Maybe you missed one step you did not do. You look at your calculations. Maybe you have some mistake in calculation. The sample is okay, but the calculations you did were wrong. You can look at the printouts of the balances. Your chromatogram, probably the sample weight was not the correct one, the one you took. Maybe the standard weight is not the correct one. So you are comparing to a different concentration from the one you should follow. You compare two and so on. So it will allow us to review your process and see what was wrong in the process that you did and led to this problem. Okay. Usually, when we talk about good documentation practice, we are talking about several elements, including clarity and legibility. All documents must be clear, no ambiguity. If you read the steps, you can understand them and follow them easily. Legibility, they are in clear font and not in handwriting. They are typed and so on. They cannot be changed. They are written using inedible ink. Yet you cannot not a pencil, for example, whether the SOPs or records. Okay, so you cannot change them, and if you did any change, it will be noticed. Reviewing, how about if it is electronic? So when it comes to electronic, also the system must have the traceability, so any change can be traced. And not you don't authorize everybody to do the change. Some people, they can only access the SOP on the system, but they cannot change it. Okay, so same thing, like you have requirements for writing that should be in edible ink, must be written, cannot be written by pencil, for example, and same time for electronic systems, then by giving the authorities or authorization for different processes, then you control who can change. And the system itself must have the ability to trace any change. Done by who? There will be controlled access. You want to access the system, then you have to use your username and password. So if the uh, privilege given to you is just only to view, then you can only view, you cannot change. If the privilege of changing is given to you, then if you did any change, it can be traced. Once we log in, we will trace the changes, what we call it, audit trail. Then I can know that this result or this procedure has been changed on that day at this time by this person. Okay. There will be some requirements regarding storage, how to be stored, for how long, for example, like records should, how many years you can keep the record. Security, who has the access uh, to these documents. Each one will have access to certain amounts of documents that are required to perform his job, okay, or his duties. And same time availability is how to make them available when I need them. We talk about also staff signatures, how we should sign, and for steps that need signature, reviewing and approving, also the authorization, approval of documents, by whom and how, and the review and how to make the review. If we make any change in the document during review or update, then how it should be done, and how can I recognize the new one, the updated document from the old one. Suppose that you have a procedure, and then now the standard testing method, for example, is UV spectrophotometric method. Then some changes in the product, whatever formulation, whatever we have interference, this method is not suitable anymore. So I made a review and then I changed the analytical method into HPLC. So now for this product, for determination of the content, I have two procedures, one HPLC, one UV. And then today, I have an analyst that he knows that nowadays, now we do the assay by HPLC. So he goes and pick up the HPLC analysis SOP and he uses it. Then a few months later, he moved to another department or he have been given another task and the new analyst came. If he doesn't know, then he has two SOPs. Which one to follow? By mistake, the first one he finds maybe the one for UV spectrophotometric method. And then he will just take and follow, and then the results will be not reliable, of course. Okay? Because of the problem of interference. So how to prevent this? How to be sure that when it comes to storage, when it comes to archiving, when it comes to the requirements, do I need to give a version number, the date of editing, and so on? These are all required by good documentation practice in order to differentiate the different versions of the same document. And then how about if the person in charge that's supposed to do this is not available? How to, somebody will do on his behalf, so anybody will just do, or must have a delegation of responsibility as a part of the documentation. Okay, so if a different person is doing the procedure from the one that's stated by the SOP, then there should be delegation of responsibility. Okay, there are essential characteristics of good documents given the abbreviation ALCOA, and these 5 letters for 5 characteristics. The first one, documents should be attributable, legible, traceable, and permanent, contemporaneous, original, and accurate. Okay. So what is the explanation? Let's explain each of them. Number one, we say attributable means information is captured in the record so that it is uniquely identified as executed by the originator of the data. Okay. So information in any record, we know who is the one who put this information. Okay. Number two, so there is signature of the person. When it comes to drafts, then who is the one who wrote, who is the one who approved, and so on. Computer system, then who is the user who edit, and who is the one who did change, and so on. Legible, traceable, and permanent, as we explained before. Legible means clear, can be read easily, they are readable. Clear means understandable, no ambiguity, allow a clear picture of the sequencing of steps or events in the record, so that all the GXP activities, whether manufacturing process or lab procedure or distribution or storage activity, can be conducted and can be fully reconstructed. Means another time, irrespective of the one who maybe the one who wrote the SOP in the manufacturing department, because he's the one who developed the procedure, then he's aware of it. Then if he follow the SOP, he knows how to perform the procedure correctly. If you give to another person that was not part of the R&D team, he did not develop the product, he must also be able, by just reading and following the steps, to perform the procedure correctly. If it is not clear enough to allow him for that, then you have a problem in your documents. Okay, so case should be can be conducted and fully reconstructed by people reviewing these records at any point during the records retention period. Okay, any time during the validity of the record. Data recorded. Okay. Same time, if you are talking about record, not instructions, then also the one who check the record during the storage time should be able to uh, fully know all the details of the record, can understand the sequence of steps done, the people who performed, and so on. Okay. Number three, C is contemporaneous. Contemporaneous means that you record at the same time you do. Data recorded at the time they are generated or observed. So you do now the analysis, you weigh a sample on the balance, then you take the printout and fix in your logbook. Then now there is a data in the logbook about the weight of the sample. At the same time you did the weight, you put it, you record it. Okay? You are now using the mixer. You sign in the record immediately after you switch on the mixer, and so on. Documents must be original also. Original data include the first or source capture of data or information and all subsequent data required to fully reconstruct the conduct of the activity. Okay, so original data include the first or source capture of data. As we mentioned, these printouts of machines and so on, or information, okay, any information, or any subsequent data required to fully reconstruct the conduct of the GP activity, whether this activity is following a procedure and recording, or the procedure itself that we should follow. Okay, we should keep copy of these documents, original data and or true and verified copies that preserve the content and meaning of the original data should be retained. We will mention later on, we will have master copies and we will have true copies. So master copy is the original document and should be kept somewhere, and then the users may have what we call a true copy. Okay. The last characteristic is to be accurate. Data should be correct, truthful, complete, valid, and reliable. Should be correct, truthful, complete, valid, and reliable. Okay. So we should record the actual data. Okay. So to fulfill these characteristics, to ensure the documentation have these characteristics, These are general requirements for good documentation practices. Number one, documents must be designed, prepared, reviewed, and distributed with care. Okay, so always we design the document according to standard templates. We prepare, we write the content in appropriate way. We make also the content clear, legible, and we check and we verify that there are no mistakes. Okay, so usually for any process, one will do, another one will check. Okay, if any mistakes will be corrected, we get the final draft, the correct one, and then will be authorized and then can be used. It will be distributed with care also, the same way we prepared it. We know it's mentioned already that who is the one that should follow or perform this procedure or fill in this record. So the one that's supposed, or the unit supposed to implement, the unit that will get this kind of documents, and other copies will be kept in the archive. We have also care who has access to these documents, who can only view, who cannot view, or even uh, cannot edit or even view, and who is the one uh, who can edit. And then also there must be a review from time to time and update of the documents with care, and then we have to be sure to have a different version number to differentiate different versions of the same document. Documents must be approved, signed, and dated by the appropriate competent and authorized persons. So usually we'll have several approvals. You are preparing, for example, good manufacturing, you are preparing, for example, master formula. So usually this one is prepared by manufacturing department or R&D. So you have first approval by preparation of a signature of R&D in charge, and then this one should be approved probably by a higher position in the company, probably the manager of the plant. So another signature, quality assurance staff must review all the documents. They have another signature also, and on the document. Okay, the date the document was drafted, the date the document was approved is recorded. Usually, each document will have an internal number, certain serial number, according to the system of the factory. Okay, so it will be approved by the persons that have authorization to do so. As we mentioned, they must be clear, have unambiguous content, so easy to understand, in other words. So anybody who read this document will understand the content and can follow easily. Okay. The title, nature, and purpose should be clearly stated. So for any document, there must be a clear title. For example, standard testing procedure, SOP, standard operating procedure, for example. For example, running the balance version, what model, whatever. Okay, and then nature of this one, is it a standard operating procedure, standard testing procedure, record, what is it, should be mentioned. What is the purpose of this one, should be clearly stated in the document. And who is the one who should perform also. They must be laid out in an orderly fashion and to be easy to check. They have usually there will be standard templates. Ensure that all the information required are there. I will show you a template at the end of the lecture. If you make copies, true copies, this is what we call reproduced documents, must be clear and legible. So you don't do original copy, you make the original copy clear, clean, and everything is good. But then you just make unclear copies and distribute it to keep the original in the archive and distribute the true copies, and the one that should be used by quality control to quality control, for example, and then, but it is not as clear as the original copy. There may be some text that is not clear or did not appear properly and so on. This is not suitable. Okay. Documents, as we mentioned, must be regularly reviewed and kept up to date. When a document has been revised, if you do a review and then we did some changes, So systems must be operated to prevent inadvertent use of superseded documents. As you mentioned, we must have a system so that we will not use the old uh, version of the document, whether it is regulations, whether it is a process, whether it is certificate or analysis, whatever is it. Only we make the current document available for use. Okay. So in the archive, we have probably all the documents and we have a database for them and we can identify the number, the document number and date of the most recent one. This is the only one we keep in the department that should follow. As I mentioned, if we have two testing procedures, for example, testing methods, then I should replace the new draft, the most recent version, I take it and it should replace the old version. I should take the old version back from the unit or department. Okay, so that this kind of confusion will not happen. Also, documents must not be handwritten. Okay, so as a standard, all the documents will be typed on computer, but previously, before computers, of course, they use the typewriter, now computers. But sometimes we have in the records, especially, there are some spaces where you have to fill in. You can use handwriting to fill in this, to write this data. For example, in the batch manufacturing record, every step you do, uh, you have to sign. If you are doing in-process control, then you use handwriting also for writing the results of in-process control tests and so on. So however, where documents require the entry of data, then these entries can be made by handwriting, but should be clear and legible handwriting. Okay, easy for anybody who read to understand. Okay, using a suitable inedible medium. So the ink cannot be removed, must be permanent. So you cannot use pencil. Okay, in the records. And when you design your template, when you make, for example, you write the batch manufacturing record or the sheet that the in-process control staff will record the results in, you should leave enough or adequate spaces in this form so that he can write at ease and in clear handwriting. Okay? Okay, now if I wrote anything by mistake, wrong, and I want to correct, so how this correction should be done? According to these requirements, any correction made to a document or record must be signed or initialed and dated. Any correction made to a document or record must be signed or initialed and dated. Either you put your signature form or your initials. Your name is Ahmed Mahmoud. Then you put AM, for example. A for Ahmed and Mahmoud, M for Mahmoud. This is the initials. And you should date. Okay, you should date. Then beside your initials or signature, you put the date or that you made this amendment. Okay, then how to do the correction? It must permit the reading of the original information. So you should not uh, scratch the old information. You should not uh, overwrite it and make it unclear. I will show you in the next slide an example of good correction and bad one. Okay, the good one must permit the reading of the original information. And where appropriate, the reason for the correction must be recorded. You should record why did you do this correction. Okay, so this is an example. For example, here they wanted to correct this written as not applicable here. Annex 563, not applicable. So he wants to change it to applicable. So how to do? There are two ways, like here in Annex 8.5. Here in Annex 8.5, you cannot see the original information, right? He just make like this. He overwrote it, completely now hidden, and then beside it he wrote applicable. If I look at it, I don't know what was written before. Okay, Same we do in records also. If you write, for example, wrong date and you want to make correction, so what to do is just to strike through. The correct one is strike through, and then your initials, and then the date that you made this correction or amendment, and then the amendment itself. Beside not applicable, he wrote applicable. This is the correct way. Okay. And another requirement is that record must be kept at the time each action is taken and in such a way that all activities concerning the conduct of preclinical studies, clinical trials, and the manufacture and control of products are traceable. So you are doing any action you are doing, so then you should have a record. Okay, any process, any procedure related to manufacturing, quality control, clinical trials. You should keep a record of everything that has been done. During the clinical trials, we are measuring the vital signs, for example. I should have a record of the vital signs of the volunteers, and I should keep it, and I can trace it anytime I want to see the data, again, the original data itself, because you may have original data and you may copy this one in tables, for example, or in diagrams. So you have diagram or table showing the results of blood pressure of the volunteers at certain time. If there is a value that looks very abnormal and you want to verify this one is a transcription mistake, they copied this value wrongly, or it was really like this, then you can trace, you can find the record where the one who measured the BP recorded the result. Okay, then you can find the reading there. Also, there are requirements regarding storage. So when it comes to storage, for critical records, they must be in a secure place with access limited to, as we said, authorized persons. The storage location must ensure adequate protection from loss, destruction, falsification, and from damage due to fire, water, and etc. So usually we have an archive room, usually with usually the quality assurance unit is responsible for all the documentation in the facility, and they have an archive with both paper-based. Usually companies prefer to have paper-based and electronic copy of the same document. So if we are referring to the electronic, we have the original written one we can refer to anytime. If we have electronic documents on the system, we have also backup another copy. So in case the system shut down, there is any problem in the server, then also still we have a backup. We can upload again to the server. Okay. So the storage location must ensure, as we said, adequate protection from loss. There is a person in charge. There are cabinets, safe cabinets for keeping. Nobody can enter without authorization. They are kept in files and in cabinets, and they will not be destroyed by rats, by uh, insects, whatever. Nobody can change in this data without authority, without tracing, and is also can be protected from damage due to fire, water, etc. This thing is okay. Fire can happen anytime, so you may not be able to protect your documents 100% from fire and water, but you can have another copy. So this is then the second point, records which are critical to regulatory compliance. The records that you should keep for certain time, for example, clinical trials record and manufacturing records and so on, that should be kept for certain legal period, probably 5 years or something. And it is critical for regulatory compliance, can be inspected by regulatory or requested by regulatory bodies anytime. Then you should have another copy in another building. Okay, if they are essential to business activities as well, must be duplicated on paper, microfilm, or electronically. And then we have one copy. It's like you have two archives, one archive in one building and the second in another building. So if there is fire here in this building, then we have another copy and that has not been destroyed by fire. Okay. Date may be recorded by electromagnetic, photographic means, but detailed procedure relating to whatever system is adopted must be available. About recording the date, uh, for performing any process on the records, on the documents itself, can be either by uh, can be recorded also by electromagnetic or photographic means, but it should follow the specific SOP for documents. Okay, as we mentioned, for documents, you must have your own SOP. Another requirement is accuracy of the record. It should be checked as per defined procedure. If the documentation is handled by electronic data processing methods, only authorized persons should be able to enter or modify data in the computer. Access must be restricted by passwords or other means, and entry of critical data must be independently checked. Okay, so uh, accuracy of record is checked as per the defined procedure. Usually, the one who will register any data in the record is will sign. So by verifying signature, we are sure that who is the one who wrote this one. And same time, we don't allow if we have electronic data on a system or a server, then I give different authorization to different personnel, depends on their position and what they are supposed to do. So some people can only view, some people can edit, and if editing done, it can be uh, traceable. So entry of critical data also must be independently checked, means if somebody entered data, there must be another supervisor or somebody to check the data entry by this person, okay, and review after him. It's particularly important that during the period of retention, when you are keeping records or files, the data can be rendered legible within an appropriate period of time. Okay, so one very clear example of this is, for example, in the lab, your okay, I give you a very simple example that you know. You go to department store to buy some grocery or fruits or whatever. You go to my DMTMG or whatever, and they will print out a receipt for you. Okay, so if you keep this receipt for 1 month at home, what do you notice? What do you notice? Did you observe this? Is the writing permanent, or the receipt will fade with time? Hmm? Do you follow me? Okay, so usually with time the receipt fade. Okay, so now if you are doing an assay procedure, you weigh this problem also in the lab. Some printers are thermal; they will print in a using certain mechanism that the receipt, the printout of the instrument in the lab will fade after some time. So this one you cannot use as a record. You cannot attach this one directly to your logbook. But what we do usually in the lab, we make a Xerox copy of the receipts that have this problem, and then we just cut and paste in our logbook. So you have to be sure that during the retention time, data can be rendered legible with an appropriate period of time. So if I make Xerox copy, then the Xerox copy usually is permanent. So you keep your logbook for the required period, for example, 5 years or whatever. Then anytime you want to check, the data are there. You can, it is legible. You can read. Okay. If data is modified, it must be traceable, as we mentioned, paper-based. Then how do you do the modification? As I mentioned in the previous slides. And if it is electronic, as we mentioned also, the system must have audit trail. What we call it audit trail is that any changes are traceable on the system. Okay. Now we go to what are the different types of documents that we usually have in our pharmaceutical manufacturing facility. Documentation may exist in a variety of forms, including paper-based, electronic, or photographic media, as we mentioned. Photographic media like microfilm or microfiche. Okay, this one we call it photographic media. Electronic, then you have a computer system and you have a server. Okay, this is electronic. And paper-based is written on paper. There are usually two primary classes or types of documentation. As we mentioned, one having a structure for certain procedure, how to follow, and the other type is record or report. This is something to record the steps of the procedure that we performed or to record certain results. Okay, so instructions, this one will give directions or requirements like the SOP, standard operating procedure, or specifications of raw materials or finished product. These are requirements. Okay, so directions like SOP, specifications document, this is the requirement. The records or reports like primary records, original raw data. Example, the executed data, batch record, analytical records, logbooks. Okay, they have the original data. Maintenance records, calibration records, temperature, humidity records, pressure differential records. Okay, so if you have a record of temperature, you have say you have a thermometer that give you the temperature of the room, and then either you go every 2 hours and record in a sheet, or say there is a printout by this one, or even electronic file that you can take on a flash disk. After 1 week or something, they have hourly records of temperature, for example. Then this is, we call this original data. If you transform this data to another form, this we call it secondary record or documents, like generated as report or certificate using primary raw data. You transfer it to, for example, you did some test, and then the result of assay was 90% or 95%, for example. Say moisture content was 2%. Whatever you did, run several tests. The original data already in your logbook. You measure the moisture content by moisture content analyzer. It gives you a printout that moisture content is 2%, and you fix this one in your logbook. This is the primary data or primary record of the moisture content. But when you write it in a certificate of analysis, among the test results in that certificate of analysis, this is, we call this a secondary record. It's not the original data. Okay. These documents usually have hierarchy, the document system from top to bottom. The less specific, very general, is on top of the hierarchy, and then the more we go down, we have more specific information or details in the document. Okay, so quality manual is level 1. This is very general, just mention the regulations. Quality manual, a global company document that describes in paragraph form the regulations and or parts of the regulations that the company is required to follow. We have to follow US FDA regulations, for example, European Union, GMP, International Conference of Harmonization, whatever. These are the regulations we follow. So this is in the quality manual. And then we can specify more in the policies. This will talk generally, describe in general terms, and not with step-by-step instructions, how specific GMP aspects like security, documentation, health, and responsibilities will be implemented. But then if you want to write every process in details, then we go to the standard operating procedures. Standard operating procedures at level 3. They will give step-by-step instructions for performing operational tasks or activities. How to use polarimeter in the lab. How to use, say, pH meter. How to use potentiometer for titration. Okay, and so on. This is a standard operating procedure. Level 4 is the batch records, test methods, and so on. Okay, Batch record, when we say the word record, then we are just documented that we make or we made certain steps, we followed. So this one, there is batch, there is master formula, this one telling how to make the batch. There is batch, so master formula is a kind of SOP, okay? If you follow these steps in each stage of manufacturing, then you can uh, manufacture this batch, and the resulting product will have the adequate quality, the required quality. But then there is record, batch manufacturing record. This one will have the same steps written, but you sign in front of each, and if there is any yield that should be recorded, anything else, and process controls and so on, they will be recorded. So this is a record of uh, how the steps has been followed and what were the results. Okay, it provides step-by-step instructions for production-related tasks and activities, besides including areas on batch record itself for documenting such tasks. So there is signature for the one who performed, and if there are any results, for example, if I need to weigh the weight of powder at the end of mixing stage, or the volume of fluid at the end of mixing stage, I should record there. Okay, testing methods, they are a kind of SOP, but because they give a step-by-step instructions. So some facilities, they don't say this is a test method and this is an SOP. They just say this is an SOP. The SOP may be for manufacture, for running equipment, for performing procedure, and maybe for a testing method. Okay, so testing method is a kind of SOP. It provides step-by-step instructions for testing supplies, materials, products, and other production-related tasks and activities. Okay, like for example, environmental monitoring of the GMP facilities, particulate count, for example, or microbial count. Okay. They typically contain forms also that have to be filled in at the end of the procedure for documenting the testing and the results of the testing. Okay, and depends. For example, you are doing in-process control, then you have to record uh, there. But if you are testing a finished product, then you are issuing a certificate of analysis. Specifications. They are documents that list the requirements that a supply, a material, or a product must meet before being released for use or sale, like what you can find in the monograph of any product in the pharmacopoeia. So, and pharmacopoeia is all about specifications and how to verify them. So they will mention to you, you open the pharmacopoeia at, for example, paracetamol tablets. They will mention to you the specifications, hardness, and they ask you to refer to the general chapters. Then general chapters, you'll find how hardness is being measured, what are the acceptable values for hardness. Friability, they will refer you to the general chapters, and same thing also in general chapters, you can find how to perform the friability test and what are the normal ranges usually. And then it will mention about another spec, the assay. It will mention to you that the content must be in a certain range, say for example 95 to 105% of the labeled content. So for example, if it contains 100 milligram of the active ingredient as a strength, say for example this is a 100 milligram tablet, then the content of each the content of tablets, or the average content, must be between 95 and 105 milligrams per tablet. And they will give you the procedure in the pharmacopoeia how to determine uh, the content determination, how to determine the content, or how to do the assay test. Okay, so just to copy the normal range, the accepted range in a document, then you are writing specifications. But for the procedure itself, for determining of hardness, friability, or assay of these tablets, then this is a testing method or standard operating procedure. Okay, usually specifications are written by usually the one who will develop the specifications is the R&D department when they do the first when they develop the product in this unit. Um, but it will be used usually by the QC department. So the quality control department will compare their test results to the specifications to determine if they pass the test. So if your product conformed to the specifications, then it passes. It didn't conform to the specifications, then will be rejected. Okay. And then another type of documents, which are all level 4, is the logbook. Logbook is a bound collection of forms used to document activities. So logbooks are used typically for documenting operation, maintenance, and calibration of a piece of equipment. Documenting operation means when we use, we record that we used it at this time. It also documents maintenance, okay, in the same logbook, maintenance done on that day. Calibration performed, we document that calibration was performed on that day at this time by whom, okay. They are also used to record critical activities like monitoring of clean rooms, solution preparation, recording of deviation, change controls, and the corrective action assignment. Okay. So we have logbooks for machine. For example, in your lab, you have fridge, you have balance, you have pH meter. Each one of them will have logbook. So if you used it at any time, you have to record. You have serial number, you add the previous number. Maybe this is the fifth process to be done or to be executed by this balance, say, and you write your name, what sample you weighed, how much was the weight, sign. So somebody came and he did calibration for the machine after use, then he will write also his name, sign, and the activities that he performed calibration, and so on. Okay, and logbook can be also, as we mentioned, for to record critical activities like monitoring of clean rooms. And you see logbook even in the toilets in our school. So this is activity, cleaning the toilet. They have a logbook. They record at what time the toilet was cleaned. So monitoring clean room, then we record at what time we did the monitoring. Okay, uh, and so on. Can we have 5 minutes break? So now we talk about the retention of documents. Retention means for how long we should keep the documents in the archive. Uh, and here we talk more about the records. Okay, for the documents like SOPs, policies, and so on, they will follow them unless they change. And we always keep archiving the old versions. But when we talk about records, for how long records should be kept. Okay, so it should be clearly defined which record is related to each manufacturing activity and where this record is located. Secure control must be in place, and we have specific requirements for how long to keep. Okay, so keeping the documents, then storing documents. When we talk about storage, security, access, as we mentioned in the previous slides, then it is defined for each document. Should be clearly defined which record is related to each manufacturing activity and where this record is located. So for manufacturing a batch, what record we need for batch manufacturing record, for example, or quality control for say for documenting whether a sample comply to specifications or no, then this is the certificate of analysis and so on. And we should have secure control. Who is the one who has access to these documents? Okay. So in the lab, we have several analysts. Each one is in charge of doing certain tests. Then he will have SOPs or test methods for these tests that he performs. Certificate of analysis, once he issue, probably will be signed by the lab supervisor, and then after this, it is the lab supervisor and his assistant authority or privilege to secure them and keep them stored and so on. Okay. So there must be also secure controls must be in place to ensure the integrity of the record throughout the retention period. Then nobody will have access to the record and change it. Okay, and these controls should be validated where appropriate, especially when we talk about electronic systems. Then there is also standard procedure for validation of computer-based systems. or electronic systems. There are specific requirements that apply to batch documentation. So if we talk about a record like batch manufacturing record, for how long it should be kept? Usually 1 year after the expiry of the batch to which it relates. As we know, we have to, at each batch production that has certain batch number, we record all the manufacturing activities and process control results and so on in this batch manufacturing record, and we keep it. This this batch of or this form is or product expires, for example, after 3 years from manufacture. Then we should keep the record 1 year more even, so for 4 years. After this, you can get rid of it. It's not required anymore by regulatory bodies. Okay, so at least 1 year after the expiry of the batch to which it relates, or at least 5 years after certification of the batch by the qualified person, whichever is longer. So like the example about 1 year, 3 years plus 1 is 4. Actually, it doesn't apply because it says or 5 years, whichever is longer. So the longer is 5 years, then you have to keep it 2 years more after. So the minimum storage period is 5 years. So how about if my batch expiry date is after 5 years, then 1 year more is 6 years, and compared to the minimum 5 years, whichever is longer, so it should be kept for 6 years, and so on. For investigational medicinal products, the same thing also must be at least must be kept at least 5 years after the completion of formal documentation of the last clinical trial in which the batch was used. Okay, so if you produced a batch for investigational medicinal products, means not yet registered in the market, it's for research purpose to be used in a clinical trial, so we should keep it at least 5 years after the completion or formal discontinuation of the last clinical trial in which this batch was used. Okay, now we'll talk about different documents in details, what should be there. Number one, about specifications. Guidelines telling that there should be appropriately authorized and dated specifications for materials we use or we produce in the manufacturing facility. So for the materials we use, because we have to test them and then we cannot use them in manufacturing unless they conform to specifications. And for our products, that we cannot release our product unless we are sure that it also has the required quality and it conform to specifications. So there should be appropriately authorized and dated specifications for starting and packaging materials and finished product. Okay, you cannot use the starting materials or raw materials or packaging materials unless they conform to specifications. You test them first, as we mentioned. They will be quarantined, given yellow sticker. You test them. If they conform to specification, then they get the green sticker and they can be used. But if not conform to specification, then red sign, red sticker, and then rejected. Okay, and same for your finished product. You cannot release it and introduce it to the market unless it conform to specifications. For each document, there must be a minimum of information that should be written. We have to prepare specifications for starting materials and raw materials. We have to prepare specifications for finished product and so on. So when it comes to specifications for starting and packaging materials, they should include the following information. Okay, number one, description of the materials, including the designated name and the internal code reference, the reference to a pharmacopoeia monograph. So sometimes you find that the raw material is maltodextrin BP. This means that this is maltodextrin, this is the name of the product, and BP means that it conforms to the specifications given in the British Pharmacopoeia. Okay, the approved suppliers, and if reasonable, the original producer of the material, a specimen of Printed material, if we talk about packaging materials, then we'll have a specimen of the packaging material with the printing on it and then color and everything. So it will be used as a reference. And then there will be directions for sampling and testing. It will not give the details of the testing procedure, but just reference to, like how to take samples and then what are the tests that should be performed. Qualitative and quantitative requirements with acceptance limit means for each test, what are the acceptable limits? So for example, I say appearance should be white to off-white, the color, for example. Then you may have particle size should be in that range. For example, flow properties, I give the results required. Uh, Content or assay, then I'm probably acceptable only 99.5 to 100.5%. This is the acceptable limit. Okay, storage conditions and precautions. Away from fire, for example, keep at certain temperature. It is a volatile substance, how to store it to prevent evaporation and so on. And the maximum period of storage before re-examination. As I mentioned to you previously in the lecture about storage, that we store the raw materials and then there must be a period for re-examination or retest. And we have to determine the potency of the material again and see whether it is still suitable to be used in the production or no. When it comes to the specifications of intermediate and bulk products, there should be also specification documents that give also uh, specifications of these products that will, at the end of each critical step, if these are purchased or dispatched to another department for further manufacture. Same thing, we have also a number of tests should be performed and then the acceptable limits. Okay, so then when it comes to intermediate, as we mentioned, for example, we have several steps for tablet manufacturing, as I explained in previous lecture. We do mixing, then you have intermediate product, the powder mix, and then after this we do granulation. You have another intermediate product, the granules, before drying, and then you have granules after drying, and then you do compression. You have then a bulk product, tablets after compression, not yet packed. Once it is packed, then it is finished product. So you have to do some testing during this at the end of each step before you proceed to the next one, as we mentioned previously about when we talked about in-process control. So they must have also a document stating the specifications of each intermediate product. What tests should be performed, and then what are the acceptable values. When it comes to finished product, then the document about specifications of finished product should include simply we can divide into probably 3 or 4 domains. One of them is about the product name and data. So we have to mention the name, designated name of the product, the code reference of the product, the formula, description of pharmaceutical form and package details, directions for sampling and testing. So the sample size, how many I should collect. These are the number of tablets or number of bottles or whatever, the dosage form units that I will collect and send to the quality control department for testing. Okay. And then qualitative and quantitative requirements. Qualitative, like the color, as we mentioned, the tablets are white to off-white or yellow, scored. They have the printing of, for example, company name and the letter FA, for example, and so on. Quantitative, then things like hardness, friability, assay, that I will get results in that are continuous variables. Okay, and acceptable limits, or sometimes we call it reference range. Acceptable limits or acceptance limits or reference range. So if the analyst this is the benchmark for him, the analyst will do the analysis according to the test methods, and then we'll record the results and we'll compare then the results to the specifications. If the results within the acceptance limits or reference range, then conform to specification. If out, then doesn't conform. Also, the storage conditions and any special handling precautions should be written, and also the shelf life of the product. Okay. Then another document is manufacturing formula, or we call it master formula sometimes, and processing instruction. This is a kind of SOP. Actually, it is several SOPs because manufacturing may be different stages. So for each stage, there will be a detailed steps for how to perform this step. So if you follow at the end, you will get the product you want. It is approved written manufacturing formula and processing instructions, and should exist for each product and batch size to be manufactured. Okay. Probably if you prepare a different batch size, you may need different equipment, you may need different production line. So usually this one will have the steps, the equipments to be used, and the amount of raw material to be dispensed from the store, tests, and so on. So if you have different batch size, maybe you need to have different document. Okay. The manufacturing formula includes, as we mentioned, details about the product. This is one domain, the name of the product, reference code of the product, internal code in the company, the code number relating to its specification, a description of the pharmaceutical form, strength of the product, batch size, and then it will have the formula, a list of starting materials to be used with the amount of each. This is the formula. It should be described. Mention should be made of any substance that may disappear in the course of processing, any substance that will be reacted, for example, and changed to another material, so we cannot trace in the final product. And a statement of the expected final yield with the acceptable limits and of relevant intermediate yields where applicable. Final yield is, for example, now we mentioned the list of materials to be used with the amount of each. So for this tablet, I need to use, for example, how many kg of active ingredient, how many kg of filler, how many kg of diluent, how many diluent or filler, same, how many kg of lubricant, and so on. Okay, how many kgs of disintegrant. If I mix these amounts, I should get 1 million tablets, for example, plus or minus 10%. Okay, this is what we call it yield. This is yield of finished product, but also there are yields of intermediate products. Like, for example, after mixing, I should get a powder mix of how many kg. After wet granulation, usually the granules will weigh this amount. After drying, the amount will drop to, for example, certain amount of kgs. Okay, and then at the end, when after I compress, I should get the how much the final yield. Okay, in number of tablets. Another uh, another data should be there, the processing instructions. What are the different steps I should follow to produce? So you will have a statement of the processing location. So in which depot unit, what production line will be used, and the equipments that will be used, and then the methods or reference to the method. Reference to the method means that use the method specified in SOP number for 20,805, for example. Okay, so you get this SOP number 20,805, and then you get the steps for performing this procedure. Okay, used for preparing critical equipment, cleaning the equipment, assembling the equipment, calibrating or sterilizing the equipments we use. Checks that the equipment and workstation are clear of previous products, documents, or materials not required for the planned process, as we mentioned before about packaging. Detailed stepwise processing instructions. So checks on materials, pre-treatments, sequence for adding materials. Add number one, add this material. Number two, add another material. Mix, for example, add fourth material, do whatever, and then critical process parameters. For example, mixing should be for how long, the time. For example, at which temperature. For example, when we are dissolving solids in liquid, or we may need some heating to speed up the solution process. Drying of granules in the oven, so at which temperature we should set the oven, for how long we should keep them in the oven, and so on. So these critical process parameters should be mentioned. When we talk about tableting, for example, then we talk about the pressure of the compression force of the machine, okay, and the fill volume also, or void volume that will fill with powder. So they will control the hardness and weight. So critical parameters for each process should be given. So the operator will set the machine at these parameters and will set the process at these parameters to obtain the required the product with the required specifications. Instructions for any in-process controls with their limits will tell you, for example, tablet machine, how many tablets to determine their weight, how frequent is it, every 30 minutes, every 1 hour, and what is the acceptable weight. It should be in the range of, for example, 300 plus or minus 10% milligrams. Okay. Where necessary, the requirements for bulk storage of the products, including the container, labeling, and special storage conditions were applicable. For example, once you collect the compressed tablets, it should be collected in a barrels of certain type, should have plastic bags inside the barrel, which material, which color, how to close them, and then they are sensitive to moisture or whatever, how to, do you need to put any moisture absorbing materials in the container till, so that they keep them dry till the time they will be packed, so on. And any special precautions to be observed depends on the type of product, protecting from light, from heat, from moisture, and so on. Okay. There is also a document for packaging instructions, and we said same as there is manufacturing formula, we have also packaging uh, instructions. So this will give you the instructions on that you need to follow for doing the process of packaging of a bulk product. So approved packaging instructions for each product will be there in this document. Pack size and type should exist also. Include or have reference to the name of the product, including batch number of bulk and finished product, description of its pharmaceutical form and strength where applicable, pack size expressed in terms of number, weight, or volume of the product in the final container. For example, this one, the pack size will be a carton box containing 2 strips, 2 blister packs, for example, each containing 10 tablets or 10 capsules. A complete list of all packaging materials required. We will need, for example, PVC film, aluminum film, what thickness with what print out on it, what printing on it, and how many rolls we need to dispense before from the store uh, to be able to pack this batch size. Okay, the size of the packaging materials, types. So size will include dimensions, including thickness sometimes, which is very important. Code or reference number relating to specifications of each packaging material. Where appropriate, an example or reproduction of the relevant printed packaging materials. So we have a sample attached in the packaging instructions of each packaging materials. And specimens indicating where to apply batch number, reference, and shelf life of the product. We explained this one during the lecture of packaging. If you remember, we mentioned about mostly the uh, the batch number and the production date and expiry date are usually not written on the primary or the secondary containers. So usually they will be printed during the packaging process. So we have instructions also where, on which part of the package to print them, and also what is the machine used for printing. And sometimes printing is by ink, by laser, okay, by heat. There are different types of printers connected to the packaging lines. It should have information about checks that the equipment and workstation are clear of previous products. Like we have instructions how to check that the equipment, as we mentioned, and workstation clear of previous products, documents, or materials not required for the planned packaging operation, and that equipment is clean and suitable for use. As we mentioned also during packaging lectures, the aim is or objective, we want to be sure that no product will get out from the packaging line with wrong label or wrong container or contaminated product. Okay. Special precautions to be observed, including careful examination of the area and the equipment in order to ascertain that the line clearance before operation began. These precautions are written in the packaging instruction document, description of the packaging operation, including any significant subsidiary operations and equipment to be used. details of in-process controls with instructions for sampling and acceptance limits. So I mentioned to you before during packaging lecture also about simple test, like use liquid with methylene blue, and then we put in this container we put the blister packs, and then we apply vacuum. So if there is if sealing process is not optimum, not good enough, then methylene blue will leak inside the blisters and will stain the tablets or capsules, so you'll know that the sealing process is not appropriate. So if nothing, no leak, that means your packing is okay and your blister packs are good enough. Okay. Batch manufacturing record, another equipment, as you mentioned. This one is to ensure to have record about the manufacturing process. We want to record that we followed all the steps mentioned in the master in the manufacturing formula, and we want to record also the in-process controls, values, yields, everything related to the batch produced. So a batch processing record should be kept for each batch processed. They will give you the template, which has all the steps to be done, all the information in general mentioned in the manufacturing formula. But additionally, there are spaces to record the data required, whether who is the person who did the step. So now we document that the step has been performed when he signed, and then any instrument checks, any yield values, any in-process controls will be recorded there. There are spaces for this. It should be based, so as we mentioned, should be based on the relevant parts of the currently approved manufacturing formula and processing instructions, and contain the following information. Information about the batch, information about the procedure, okay, and the people who do it, and information about the yields and critical parameters and in-process controls. It contains the name and batch number of the product. So this will be a space that you have. When it comes to the name is written there, but batch number is a space you have to fill in, because it is made generally for this kind of product with this strength and dosage form. You receive it, the empty template, then every time we produce a different batch number. So we have today we produce batch with certain number, we record the batch number, and we fill in the whole document or whole record. After a few months, we produce another batch from the same product. We get the same template again with empty spaces, and then we record the new batch number on that date. Okay, dates and times of commencement, all this you have to fill in. Of significant intermediate stages, so probably we produce up till today we make the drying, but we keep the granules, and tomorrow the compression. So each process we write the time and date that has been done, and at the end when you produce the bulk product and of the completion of production. Identification or initials of operators who performed each significant step of the process, and where appropriate the name of any person who checked these operations. So you are the operator of the machine. You sign on each step that you perform. There are somebody to verify and review after you. He will sign also. Okay. So many steps that will be somebody to perform and somebody to verify. Both of them will sign. Batch number and or analytical control number, as well as the quantities of each starting material actually weighed, including batch number and amount of any recovered or reprocessed material added. All of them will be recorded there. Any relevant processing operation or event and major equipment use recorded. They are already written, okay? But you have to sign, confirm that you followed this step, you operated this machine, you followed the machine setting given to you in the steps and so on. A record of the in-process controls, as we mentioned, and the initials of the persons carrying them out and the results obtained. So you collect in-process controls and you send to the lab, then you will sign that you collected this number of samples and you sent to the lab at which time. The lab send you the results back, then you record the results and you attach the certificate sent by the lab. So if you are the one who do the in-process control, same like following the weight or hardness or friability during production in the production line, then you are the one who record each time the results. And then the product yield obtained, as we explained, at different stages of manufacture. Notes on special problems, including details with signed authorization for any deviation from the manufacturing formula and processing instructions. Okay, so notes on any problem. You have problem with mixing uniformity, you write notes. And what action did you do to rectify this problem? With signed authorization for any deviation. You increase the time, you change to another machine, another mixer. Whatever you do, you have to mention what did you do. Okay, and that you got approval for this one before you do it. And approval by the person responsible for the processing operations. The person in charge of the unit itself must sign also. So operators will sign for each step they do, and then there is somebody to verify, and the person in charge, the manager of the production line, also will sign the approval. Okay. If you have a continuous monitoring, okay, like a validated process is continuously monitored and controlled, the process, as we mentioned in the lecture of process control, sometimes it is automatic, then there is automatically generated reports. Okay, these reports enough to be limited to compliance summaries and exception data reports, exception or out of specification data reports. Okay, but as long as the procedure is the data are, because the control itself is giving feedback to the system and then keeping the parameter that we want to control controlled. So usually nothing will be wrong, just summary of compliance, evidence of compliance to uh, the procedure. Only we need reports in case of out of specification data. Okay. Then batch packaging record. This is, so we have packaging instructions. This one will explain how to do the packaging, similar as manufacturing formula and processing instruction, telling how to manufacture the batch of medicine. And we have batch manufacturing record, this one to give a record of the what has been done and what are the results during the manufacturing process. Opposite to this one, we have batch packaging record. This one will give you the same details about the process of packaging. Okay, this one should be kept for each batch or part batch process. Should be based on the relevant parts of the packaging instructions. So you have the steps in the packaging instructions. When you prepare the documents, you will copy the same steps again in the batch packaging record, but you have to add spaces for signature of the one for the operators and signature for the one who verify or review. And you have to add also spaces for writing in process checks or in process control results. Okay, so we have the same data also, name and batch number of the product, date and time of packaging operation. The person will sign with his initials, usually with initials and date. Each one who do a significant step, the operator of each machine doing the steps of this on this machine, he will sign in front of all the steps written in the batch packaging record that he performed. Okay, and the one who check also will sign. Records of checks for identity and conformity with the packaging instructions, including the results of in-process controls. So we have also record that you checked, for example, you have samples in the packaging instructions of the packaging materials, and you received packaging materials from the store. Okay, you fix on the packaging lines to use in packaging process. So before you attach them, you check that you receive the correct material by comparing with the samples retained in the packaging instructions file. So there is a step written that you have to do this process. You did already, so, and this step is written also in the batch packaging record, so you sign that you did, and you sign the findings that they conform, they match, they are similar, okay? If different, then you sign that different, reject, return to the store, and request another one, and then you write the result of the other one. Okay, so this is checking for identity and conformity of the packaging material. And also in process controls, what we mentioned about results of tests should be written. I should write the results. So in the packaging instructions, I have only I should perform this test, how I perform. But in batch packaging record, I should record the result, whether the test is successful or fails. Okay. Details of packaging operations carried out, including references to equipment and packaging lines used. Whenever possible, samples of printed packaging materials used, including specimens of the batch coding, expiry dating, and any additional overprint. Notes on any special problems or unusual events, including details with signed authorization for any deviation from the packaging instructions. Same concepts like the batch manufacturing records. Quantities and reference number or identification of all printed packaging materials and bulk product issued, the amount that you received and you used to use in your production line, how much of them used, how much destroyed or returned back to the store they were in excess after finishing the process. Okay, where there are robust electronic controls in place during packaging, there may be justification for not including this information. If you have electronic control and already they are recording such data, so no need for you to write by hand in the document. And then at the end, the person in charge of the packaging line should approve the packaging operation at the end after reviewing all the steps. There are documents for procedures, some procedures and records for them, like for receipt procedure. There should be written procedure and records for the receipt of each delivery of starting materials or packaging materials. When you receive them, what to check and what samples, how many samples you take and how to take them. Okay, there should be written procedures for the internal labeling, quarantine, and storage of starting materials, packaging materials, and other materials as appropriate. Okay, so the data on the records of the receipt include name of the material, delivery note sent by the supplier, and the containers. Okay, the name of the material on the delivery note sent by the supplier and on the container. They should be same. The in-house name or code of material, the one you are using in-house means inside your company, the date of receipt, supplier's name, and manufacturer's name, manufacturer's batch or reference number, total quantity, and number of containers received, the batch number assigned after receipt, and any relevant comment. There should be instructions about sampling and for testing. So there should be written procedures for sampling, which include the methods and equipment to be used, the amounts to be taken, and any precautions to be observed to avoid contamination of the material or any deterioration in its quality. So if your sample, for example, is a sterile product, sterile powder, for example, for reconstitution, or sterile, say, penicillin powder that will be used for production of penicillin injections, and you may have penicillin powder that will be used for preparation of tablets or no penicillin tablet, no serum, right? Or say amoxicillin for injection or for tablet or serum. Okay, so when you take samples from the sterile powder, do you open it in the same environment, same as that is not sterile, or there must be special precautions to keep the remaining material in the container sterile? Okay, so and then I explained to you before in one lecture about the sampling tool, right? Do you remember? So it will explain to you what sampling tool you use, how many samples you collect from different parts of the container, for example, the barrel or the package, and so on. It will describe the sampling tool and the number of samples collected from which positions, okay, and what precautions to observe. Testing also, there should be written procedures for testing materials and products at different stages of manufacture, describing the methods and equipment to be used for testing, and the tests performed should be recorded. So testing methods, as we mentioned in the document, they will give instructions step by step how to perform the test and which instrument to use. Other documents, this is last slide almost. Other documents, we should have written release and rejection procedures, when to release certain batch of finished products, or how to the requirements to release starting material or packaging material received in the store should be available for materials and products, and in particular for the certification for sale of the finished product by the qualified person. So this actually be done not only based on certificate of analysis, but after the last is certificate of analysis, but a lot of documents will be reviewed, and then the final procedure for release of the batch. All records should be available to that qualified person. So he will review the certificate of analysis, the testing methods done, and the batch manufacturing record, everything. A system should be in place to indicate special observations and any changes to critical data. He should be able to trace if any data has been modified. So to verify that these data are true and accurate and not falsified. Okay? Records should be maintained for the distribution of each batch of a product in order to facilitate recall of any batch if necessary. So I should know to whom this batch was distributed. So if there is a recall, I know how to, or who I should contact for recall. Clear operating procedures should be available also for major items of manufacturing and test equipment. We will have SOPs for equipments, and they will give you step-by-step instructions how to run them. Logbox also should be kept, as we mentioned, for major or critical analytical testing. Production equipment areas where product has been processed, they should be used to record in chronological order. So I mentioned to you there is a serial number. The one who used first writing number 1 and then the details about what he did. So the second one, the newer in time will be next, number 2, number 3, and so on. This is in chronological order. Any use of area, equipment, calibrations, maintenance, cleaning, or repair operations, including the dates and identity of people who carried these operations out, will be recorded, as I explained before. Inventory of documents within the quality management system should be maintained. So we have inventory, and so means that all the documents in use and stored in the company are recorded, and I know what documents I have in the archive, what documents I have in quality control department, what documents I have in manufacturing department, and so on. Okay. Usually for such guidelines, we can refer to guidelines like European Commission guidelines, rules governing medicinal products in European Union, good manufacturing practice guidelines on good manufacturing practice specific to advanced therapy medicinal products. They have chapter 4, which is about documentation. I can refer to Annex 5 of World Health Organization also, guidance on good data and record management practices. And they have some few papers you can also use. Also they have PICO guidelines, they are in detail about GMP and everything related to GMP. You can refer almost to PICO guidelines. Good practices, here we refer to good practices for data management and integrity in regulated GMP, GDP environments. Okay, and they have few papers you can refer to. Thank you very much for following, and I hope you have good understanding. If any issues still you can raise on the forum, I will be glad to reply to your questions.